Okay, these came out really funky. Just here's our rules of exponents. Some of this you don't need, but I'm just going to go through it anyway. So first off is your product rule. So if I have x to the a times, oh geez Louise, already, x to the b is equal to x to the a plus b. So if you're multiplying with the same base. So if I have x to the third, times x to the 7th, that's going to be x to the 10th power. Okay, you have your power rule. So if I have x to the a to the b power, well, that's the same thing as x to the a times b. In this case, if I have like, I don't know, y to the 6th squared, well, I know that that's going to be y to the 6 times 2, which is y to the 12th. Just a little bit of a reasoning over here. This is pretty obvious. I have 3 x's here and 7 x's here, so I have a total of 10 x's. This here, my y to the 6th squared, that means that I have y to the 6 times y to the 6, which means I'm multiplying a total of 12 y's if I showed that. So again, that's why the rule is the way it is. Your quotient rule, like I showed you this in class at some point. If I have x to the a over x to the b, well, what do I do there? I'm going to subtract my exponents. That's going to be x to the a minus b. So this is b to the 5th over b to the 2nd, which is going to be b to the 3rd power. Our next one is our negative exponent rule, which makes perfect sense. It follows our quotient rule. So if I have something like x to the 3rd over x to the 5th, well, I know that that's going to be x to the 3 minus 5, which is x to the negative 2. I also know x to the 3rd looks like this, x to the 5th looks like this. These divide out, and this is also 1 over x squared. So these two here, right here must be equivalent expressions. So if I have x to the negative a power, that is 1 over x to the a power. Okay. Also, alternatively, if I have 1 over x to the negative a, that's going to be x to the a power. All right, so if I have, let's say, q to the negative 3rd power, that's 1 over q cubed. I don't love that example. I'm going to give you one more. So if I have 5/6 to the negative 1st power, that is actually going to be 6/5 with a positive exponent. So, okay, and then of course your 0 exponent rule. This actually goes back to the same thing. If I have x over 3rd over x to the 3rd, well, if I follow the rules, that's going to be x to the 0 power. But I know x to the 3rd over x to the 3rd, these would all divide out to be 1, so the answer is also 1. So x to the 0 power must be 1. So if I have, let's say, negative 1/3 x to the negative 7th y to the 2/3 to the 0 power, that is simply going to be 1. So don't let me fool you. Okay. So we are going to just do a few examples. So we're asking you to simplify. This is negative 6 to the 4th. That has nothing to do with negative exponents. This is negative, and then we have 6 to the 4th, which is 1,296. And then this right here is going to be 1/4 times 1/4, which is 1/16. So this is going to be negative 1296 over 16, which is equal to negative 81. I caution you, the negative is on the outside. So when it is on the outside, we treat this like a negative 1 times 6 to the 4th. The 4th goes with a 6, but it does not go with a negative 1. This next guy here, there are a couple things. I could flip it first. I like using distributive property, so my power to a power. So I'm just going to take this in a couple steps. This is 5 to the 0 times -2 over 3 times to the -1 times -2, which is 5 to the 0 over 3 squared, which is 1 over 9. Our next guy here, these are separate. This is -3. I'm going to rewrite this with commutative property times 8 times p to the -2 times p to the 6. So I'm putting my like terms next to each other. This is going to be -24 p to the -2 plus 6 -24 p to the 4th. Okay, using when I have those same bases. This is a multi-step one. I like to simplify first. So I first look at my 57 over 3, which is 19. I have x to the 4th over x to the 1st. Remember that there's a first power. That's going to be 4 minus 1. This is y to the -2nd minus -3 times 11x cubed y. 19x cubed y, -2 minus -3 is to the first power times 11x cubed y. I'm going to rearrange, you guys don't have to do this, times x cubed times x cubed times y, and I consolidate all of this. Sorry for being interrupted. And so this is going to be 209 x to the 6th, y to the 2nd. Okay. This next guy here, 3/4 r to the -2nd, s to the 5th. I kind of do my order of operations. This is going to be -4 squared, r to the 3 times 2, s to the 2nd. Okay, I can simplify before I move on. I have 3/4 r to the -2nd, s to the 5th, times 16, r to the 6th, s to the 2nd. I can rearrange. I have 3/4 times 16 times r to the -2nd, r to the 6th, s to the 5th, times s squared. So 4 goes into 16 4 times, so I have 12. And then I add my exponents here, so that's going to be r to the -2 plus 6, which is going to be r to the 4th. And then this right here, to consolidate, this would be s to the 5 plus 2. So this is going to be s to the 7th. Just some basic division before we do some crazy ones. Okay, the negative we kind of keep on the outside. This 18 over 42, I asked myself, can I simplify 18 over 42? And 6 goes into both of them, so divide by 6, divide by 6. So this is going to be 3 over 7. Keep my negative sign. This is going to be a to the 8 minus 5, b to the 4 minus 7, -3/7, a to the 3rd, b to the -3rd. Now, oftentimes we ask for these to be written with no negative exponents. So we send anything that has a negative exponent to the denominator, if it's in the denominator, into the numerator. So this is going to be negative 3/7. A stays in the numerator, but actually B goes in the denominator. First off, I look and see what I can simplify on the inside. So 39 over 24, I know 3 goes into both of those. So that's going to be 13 over 8. It's going to be c to the 7 minus 2, d to the 4 minus 5 to the second power. You don't have to do this in this many steps. 13 over 8, c to the 5th, d to the negative 1st, to the second power. All right, and then I distribute my exponent to each part. 13 over 8 squared, c to the 5 times 2, d to the negative 1 times 2. That's 169 over 64, c to the 10th times d to the negative 2nd. My final answer is 169 stays in the numerator, c to the 10th stays in the numerator, 64 is in the denominator, and d squared is also in the denominator. So there's my answer to that one. This next guy, I look inside the parentheses just to see if I can simplify anything. I can't, so I distribute my exponent. This is 1/2 to the 3rd, m to the negative 6th, n to the 9th, times 1/8 to the negative 2nd, m to the positive 2, n to the negative 8. I rearrange things, so I have my 1/2 to the 3rd times 1/8 to the negative 2nd, m to the negative 6th, m to the 2nd, n to the 9th, n to the negative 8th. Okay. With this one, there's a whole bunch of different strategies. I feel like I always pick the wrong one, but when we have plain numbers here, this is going to be 1 over 8 times, now it's to the negative 2, so that's actually going to be the same thing as 8 to the positive 2 power, so 8 squared, because it's the reciprocal. I don't know, I think that's the wrong route. Let me do this. So this is going to be 1 to the negative 2, 8 to the negative 2. If you have a negative exponent, it flip-flops. So the 8 to the negative 2 goes in the top, becomes a positive 2. 1 to the negative 2 goes in the bottom. And so then I have 1/8 times 8 squared. 8 goes into 8 squared. And so my answer is just going to be plain old 8 here, at least this part of the problem. So sorry if that's, I distributed the exponent, then flip-flop them. To the same spot. All right, and this would be great if this actually worked. Okay, there we go. Sorry, that was a little snafu. So this right here is 8. The rest of this, so then I have the m to the 6, that's going to be m to the negative 6 plus 2. So this is going to be m to the negative 4. And then we have, remember that's n to the 1st, so it's n to the 1 plus negative 8. So that's going to be n to the negative 7. The 8 has a positive exponent, so my 8 stays in the numerator. M to the 4th, negative 4th, has a negative exponent, n to the 7th as a negative exponent. So they get sent to the denominator. So there we go. I write 1 instead of 9. Yes, I did write 1 instead of 9. This is 9. This is 9. There we go. Sorry, guys. This is positive 1. And then this is going to be positive 1. So this n actually does stay in the numerator. Sorry. Of course, it wouldn't be Miss Holly notes if it didn't have a mistake. Okay, so we actually don't have too much more. Number 9, it's just dealing with the same thing with rational exponents. I'm just going to rewrite this. This is 4 times 3 times x. I have the same base, so this is going to be negative 5/4 minus or plus negative 1/3. So this is going to be 12x. I get a common denominator. So this is going to be negative 15 over 12 minus 4 over 12. Okay, so this is going to be 12x to the negative 19/12, which if I wanted you to write it with positive exponents would just be 12 over x to the 19/12. So this is actually an or one. Typically, well, you see sometimes it's written that way, sometimes it's not. So not too worried about the negative exponents. So first thing, I distribute my exponents. This is going to be x to the negative 2, y to the positive 4/3. This one's very simple. So I'm just going to send my x to the denominator. So it's going to be y to the 4/3 over x squared. This is not going to be that proper because this is a root, but I'm just looking for your basic answer. So there are a few things that I will accept. Okay, this guy right here, just I have my 3 over 4, can't do anything about that. So I just leave that 3 over 4. This is going to be x to the negative 7/4 minus 2, and then times y to the negative 1 minus 2/3. So I have my 3/4 here. This is x negative 7/4 minus 8/4 times y to the negative 3/3 minus 2/3. 3/4 x to the negative 15/4 y to the negative 5/3. You might see, but probably won't see because you can't have radicals in the denominator. You could also see it as, so it could be this here, or we have 4x to the positive 15/4 times y to the 5/3, positive 5/3 if it was sent in the denominator. So, okay, and then we get to a really nasty one. You just got to deal with it. I like to combine everything, my numerator and denominator, and then worry about numerator and denominator. So first off, my numerator, I'm going to leave it alone. So that's your m to the 5/4, n to the negative 2nd, p to the 4/3. I'm going to distribute my exponents, so it's going to be m to the 1/3, n to the 1/2, because 3/2 times 1/3 is 1/2, and then p to the 0 is 1/3, so we don't have to worry about that, so we distribute it to all three. So p to the 0, so this is still going to stay p to the 0, and then we have our m squared, n to the 3/2, p squared. Okie doke. So still have some stuff to simplify here. I leave my m to the 5/4, n to the negative 2nd, p to the 4/3. I know I can combine my m, so this is going to be m to the 1/3 plus 2. this is going to be, I have my n's here, n to the 1/2 plus 3/2. That's nice that it has that. And then I have p to the 0 plus 2. So go through m to the 5/4, n to the -2nd, p to the 4/3 over 1/3. So that's going to be m to the 1/3 plus 6/3. This is going to be m to the 4/2, and this is going to be p to the 2nd. Rewrite it again, m to the 5/4, n to the -2, p to the 4/3 over m to the 7/3, n to the 2nd, and p to the 2nd. All right, now, I know, this one's tedious. So now I combine everything. So it's going to be m to the 5/4 minus 7/3, n to the -2 minus 2, and p to the 4/3 minus 2. It's going to be m to the 5/4, so that's going to be 15 over 12, and then 7 times 4, that's going to be 28 over 12, times n to the -4, times p to the 4/3 minus 6/3. So one of my final possible answers is going to be m to the 43 over 12, n to the -4th, actually it's positive 15, sorry, 13 over 12, there we go, so this is going to be to the -13 over 12, n to the -4, p to the -2/3, and so you have this as an answer, which is nasty enough, or you could have 1 over m to the 13/12, n to the 4th, p to the +2/3. So it could be one, or it could be the other. All right, rewriting as powers of 2. You're going to have to do something similar. So 16 as a power of 2 is just 2 to the 3rd power. 1 over 16 is 1 over 2 to the 3rd power, which if I write that, it's going to be 2 to the -3rd power. For 1, this is actually really handy. Anything to the 0 power is 1, so this is going to be 2 to the 0 power. This next one's pretty interesting because this 4 can be written with a base of 2. Well, yeah, this is actually 4 is 2 times 2. And then we have our times 2 to the n here. So I'm going to rewrite this. This is going to be 2 squared times 2 to the n. And when I multiply, I add my exponents. So this is going to be 2 to the n plus 2. And the very last one, I have 2 to the m power. 8 is actually 2 to the 3rd power. That's what I messed up. This should have been to the 4th power. There we go. And so what do I do with my exponents here? This is going to be 2 to the m minus 3 power. So that's how to rewrite with a base of 2. Okay, and then the last thing are your rational exponents. So so if I have a to the 1/2 times a to the 1/2, that's going to be a to the 1/2 plus 1/2, which is a to the 1st power, which is just plain old a. So the same thing is true for this. If I have radical a times radical a, that is going to be radical a squared, which is just plain old a. Okay. So I have this, so you see, if you see, I have a for both of these, So a to the 1/2 power, so therefore a to the 1/2 power must be the same thing as the square root of a. We do the same thing here. This is a to the 1/3 plus 1/3 plus 1/3, which is a to the first power, which is a. Also, if I do a cube root times a cube root times a cube root, well, that's going to be the cube root of a cubed, which is also a, which means that a to the 1/3 power is equal to the cubed root of a. So basically, when you have a denominator like that, it drops it to its, or you can rewrite it. This right here, your denominator is always your root. So first off, our first rule is if I have, let's say, a to the 1/n, that's going to be the same thing as the nth root of a. So if I have 7, or actually 27 to the 1/3 power, that is going to be the cubed root of 27, which is 3 in this case. And then our second rule, or our second thing, is that if I have a to the m/n power, that is going to be the nth root of a to the m power, or you could actually write it as, I know that that could also be a to the m power, and it's going to be the nth root of that. So it just depends on whatever is easier. So for example, if I have x to the 3/4 power, that is the same thing as the 4th root of x to the 3rd, or it could be the 4th root of x to the 3rd power. Both of those actually work. So first off, we're just rewriting these as a single power of 3. I know a root is the same thing as the denominator, so this is going to be 3 to the 1/3 power. This one right here is 3 to the 1st times 3 to the 1/3 power, which is 3 to the 1 plus 1/3 power, which is 3 to the 3/3 times, or 3/3 plus 1/3, which is going to be 3 to the 4/3 power. Okay, and all this was asking for is write it as a single power of 3. And then last but not least, this guy right here. This is 1 over, this is 3 squared times 3 to the 1/3. Okay, which is 3 to the 2 plus 1/3, which is 3 to the 6/3 plus 1/3, which is equal to 1 over 3 to the 7/3. But if we want to bring that up, we have to remember to send it back down. We have to have that negative exponent. So this is your answer here. All right, last 3 examples, so not too big of a deal. Just simplifying. So for this here, okay, I have, this is going to be 1 over the cubed root of 64 and the cubed root of x to the 5th. Actually, okay, it's the cubed root of 64, and then this is going to be x to the 5/3 power, which is 1 over the cubed root of 64 is 4, and then this is going to be x to the 5/3 power. Okay, and so you could also write this as 1/4 x to the negative 5/3 power. This next guy right here, my negative exponent, this is the same thing as 1 over 125 to the 1/3, which is the same thing as 1 over the cubed root of 125. So this is going to be 1 over 5. And last but not least, this one's a super weird one. I have 8x to the 5th over 4x squared minus x cubed over 4x squared plus 5 square root of x cubed over 4x squared. Now I should have left some more room in this box because we have plenty of room on this page. I know 8 over 4 is 2, x to the 5th, x squared, that's going to be 5 minus 2, that's going to be x to the 3rd. Okay, for this one, I know that that's going to be x cubed over x squared, so this is going to be 1/4 x to the 3 minus 2 is 1. Okay. And then this last one here, I'm going to rewrite this with my, actually, you know what, I'm going to draw these steps in because I think it might be easier to see. So I have 2x to the 5 minus 2 minus, and then I have x to the 3 minus 2 over 4 plus, now I can't do much with these exponents. The 5 and the 4 kind of stay as is. This is the square root of x cubed, so that's going to be x to the 3 halves. This is x squared, so this is going to be 2x to the 3rd minus x to the 3 minus 2 is just x, so it's going to be 1/4 x plus 5 over 4 x to the 3 halves minus 2, so 2x cubed minus x over 4, or 1/4 x, plus 5 over 4. Now 3 halves, so 2 is actually 6 halves, or 6 halves, 4 halves, there we go. So this is going to be x to the negative 1/2. Okay, so that one was super confusing. Hopefully I didn't confuse you too much. Do the homework, and I'm sure you'll do great.